I hope that you just watched Gravity is Mass. Or was it Mass is Gravity? Doesn't really make any difference. The last part of what we were talking about was trying to relate some numbers to what's going on here. So on this board, this is how I ended up. The mass is gravity, and I didn't fill in this fudge factor. Well, this fudge factor times the mass of Earth equals this gigantic number, 10 to the 14, million, thing like that. Well, how can that be true if we're trying to figure out what the uh, force is on 1 kilogram, 2.2 pounds? Well, here's how it works. This distance down here, here's the mass of the object, let's say 1 kilogram, and this distance down here, this distance is not the distance of the 1 kilogram from the floor, it's the distance of that 1 kilogram to the center of the earth. And the center of the earth distance is huge, so this huge number down here gets squared, and then you'll see that the resulting number is not going to be that big. So that's why this thing looks so nutty. What's the title of this one? It's Wind and Weather. So where's the weather? The weather's in the air, obviously, and somehow we're going to figure out what makes wind blow. What does gravity have to do with the air? The air is just there. Why do we have to worry about the gravity? The gravity makes a big difference, and I'll start to explain why. Let me get my globe. Okay, here's the Earth, and the atmosphere is about a paper thin thickness if we do it to scale with this globe. That paper thin thickness is made of air molecules. Why don't the air molecules just drift off into space? Do the air molecules have mass? Yes, the air molecules have mass. They have a really teeny tiny mass for each one of those molecules, but they are attracted, just like that 1 kilogram mass, just like the moon, they're attracted to the surface of this Earth. So, why don't all of the air molecules just land on the surface of Earth and then there's a vacuum beyond that? If I were to take a single molecule and in a vacuum where I had just a single molecule, if I drop that molecule, it goes straight to the Earth and it would sit on the surface. But air molecules don't come in individual pieces. There's a whole bunch of them. And at room temperature, those molecules are running around about 1,000 miles an hour this way and that. And those air molecules build up to where some of them get a little bit higher and knocked away from the surface of the Earth. Some get higher, and it just keeps going until finally the air starts getting thin because fewer air molecules are brought there. Just like in a swimming pool, if you go way deep in the water, the pressure of the water gets higher and you have a density is higher. Same thing is true with the air. So that gives us a good reason why gravity has to be a big deal in what we're talking about. Okay, I've got this paper thin atmosphere, if we do it to scale on this globe, and why does that air move? Why do we have winds? There's very few times when you go outside where there's no wind, where the air is not moving. Certain cases that occurs. But for the most part, that isn't true. What happens when the sun shines on those gases? They heat up and they start moving. And as they start moving more, the higher temperature gas will start moving up higher in the sky. When that happens, then that higher air temperature tends to go to the colder air temperatures. So the air is going to move. Okay, I've got a picture on the board here, and this is so I don't have to keep holding that globe. That's pretty awkward to do that for all these discussions. I mentioned that the heat of the sun creates the hot air that then starts moving things around. Where is the sun going to be the hottest? That's right at the equator. Let me spell that, get that spelled a little bit better. Or let's just forget about it. You know what that center thing is. That's the equator. You know how to spell equator. Anyway, the hottest point here, use red here, there's the hottest point on the earth, is at the equator. Those winds, or as wind hasn't started yet, but those air molecules heat up and they start going up into the air. And one thing you have to realize is that hot air goes towards colder air. If you ever open up a window or something and it's real hot, that hot air is going to go towards the colder air. So this hot air is going to seek out the coldest spots. Where are the coldest spots? Right at the poles of the earth. So we're going to have a wind that kind of goes up this way. And then a wind is going to, or I'm sorry, the air is going to cool off that air. It's going to get denser, and then it becomes high pressure air. Well, high pressure air is going to go to lower pressure air. Hot air is going to go towards cold air. High pressure air is going to go to lower pressure air. So what's going to happen is we'll have these currents that are going to swing down this way. So all the currents of the earth are going to go from the equator up to the pole. We'll have another set of these things down here doing the same thing. One going this way, one going that way. And so all we would have is north and south winds. That's all we would have. But that's only true if the earth wasn't spinning. If the earth spins, then you've got the fact that, well, let's see, the earth is going from west to east. In other words, let's see, is that correct? Yeah, west to east. And when that happens, then it's going to start dragging some of this air with it as it rotates. So we're going to tend to have these currents are going to tend to go from west to east, and that's the way the wind is blowing for the most part. This is just a real simple picture where there's no other deviations. If we have any deviations in pressure or temperature, differences in temperature, then we're going to have winds start blowing to the colder sections, or we're going to have it blowing towards the lower pressure sections. And all of the wind is going to be created by one of those two items, or both, probably. So I hope that answers the question of my viewer about why the wind blows. If not, put down there in a comment and we'll try to clear that up more. This could be a really complicated discussion, but I think you get the idea. Hot goes to cold, high pressure goes to low pressure.